Welcome to our final lesson in Unit 6A. In this lesson, we're going to kind of bring together all of the other skills that we've worked on into solving quadratic equations. And we're going to solve them by factoring. Okay, so here's the method to our madness coming to fruition. So in this, we have here 2x plus 3 and then times the quantity x minus 4 equals 0. So if you think about this, if you have two things multiplied together and they equal 0, let's say a and b, a times b equals 0, then either a has to be 0 or b has to be 0 because, right, anytime we multiply by 0, or we get 0. So that's where this zero product property is coming from. If we have two things multiplied together, we know one of those two things has to be 0. So in this case, we've got two binomials being multiplied together. So one of those binomials has to be equal to 0, or potentially both of them. So what we do is we place each of the binomials equal to 0. And now we have two equations that we can solve, okay? And just our two-step equations here. So we end up getting either x equals negative 3/2, right? Or 1.5. I like the fraction better. Or x equals 4. So those are our two solutions to this quadratic. Okay, x can be either one of those, and then that is going to give us the result we want. Okay, now this only works if you have two things being multiplied together that equal 0. If it equals a different number, it's not going to work. You can't use the zero product property, right? Okay, let's try one more example. So here is the zero product property. If a times b equals 0, then either a has to be 0 or b has to be 0. Okay? And you can see here how we have an example of x plus 3 times x plus 2 equals 0. So then x plus 3 equals 0 or x plus 2 equals 0. So in that case, x would either equal negative 3 or x would equal negative 2. Okay. So let's try this. Now notice here we do not have two factors. However, that trinomial looks like maybe we should give it a shot and try factoring, right? So I'm going to factor, and again, I kind of use my guess and check, right? I know both of them are going to be x there for my first term. One's going to be a minus, one's going to be a plus, okay? Two numbers that multiply together give me 42 and have a difference of positive 1. So I'm going 7 and 6, right? 7 and 6. And notice how I put the 7 with the plus and the 6 with the minus because, again, that difference is a positive 1, right? So now I can set each factor equal to 0, and I can get my two solutions, okay? So here I end up getting, and make sure you think about this as you do it. Too often students make sign errors in this final step, okay? So x equals 6 or negative 7. Those are our two solutions. See how we solved by factoring there. Final example. Here's a real world example. Now this is the tough one. Okay, so here we have a flat pattern that we use to build a box. Okay, and the height is 1. So imagine that those heights are going to be folded up, right? And then you've got the width and the length. Okay, now I want you to envision what the dimensions of this total page is, okay? What are the dimensions of the total page? So notice how we have those 1-inch squares removed, right? So that means this true width of this paper is going to be x plus 2 because it's the x plus the 1 inch on either side. And then the dimension over here, okay, notice how the large part is x plus 3, but then we have those 1-inch squares again. So truly the dimension of this sheet of paper, okay, that is used to create this box that we talked about here is going to be x plus 5 times x plus 2, okay? So now we're told that the sheet of paper is 132 square inches. Okay, so how did we get that sheet of paper that way, right? Well, what we're going to do here is we're going to say x plus 2 times x plus 5 equals 130. Okay, see what I did there? I just set up, because that sheet of paper, the dimensions, okay, are set up that way. Now, notice how I can't use my zero product property yet. All right, our whole goal is to find the dimensions of this box. So the first thing I'm going to do is FOIL, okay, and I get x squared plus 7x plus 10 equals 130, okay? Now I can't use my zero product property because it has to equal 0. So I'm going to subtract 130 from both sides. Now notice what my equation equals. See how I did that? So now that my equation equals 0, I'm going to factor it, okay? And I'm going to, again, I'm going to use all of my fabulous factoring skills. And I know my first term in both is going to be x. I know I have 1 plus and 1 minus, okay? So now my question is, numbers that multiplied together give me 130, or excuse me, 120, and have a difference of 7. So, okay, so 60 and 2, way too far apart. How about 20 and 6? Still too far apart. How about 15? 15 and what? 15 and what gives me 7, or 120. 15 times 8. 15 times 8 does give me 120. So I'm going to put my 15 with the plus and my 8 with the minus, right? So, and I can check, I can FOIL it back, and I do get the x squared plus 7x minus 120. Okay, awesome. So now what I'm going to do is I'm going to set each factor equal to 0. Okay, and again, watch your signs. So I get x equals 8 or x equals negative 15. Okay, now in this case, does it make sense that maybe our width of our box is negative 15? No. So in this case, 8 is going to be our x value that we really want. So now we can go back to our original situation here. And again, remember that we have x is 8, right? So that could be our width. Our width could be 8. And that makes our length 11, right? And then we were already told that our height is going to be 1. So there are our 3 dimensions of our box. As always, make sure you finish that post video check. Let me know. This last problem here is usually the one most students want to talk about in class. If you have any other questions, send them to me, and I'll see you in class.